evening and welcome. It's Monday, it's time for the mathematics news. Hello! So today's topic is brand new. We're moving on to vectors. And vectors, there are a number of different types of questions, but I think we should just talk generally about what vectors are, and then I've got some practice for you on Manga High. It's a website we used back in October, but they've extended our free subscription, so I'm going to be using that for a bit, which is quite nice. But vectors is a small topic, but it can have some tricky questions. I want to talk about what they are. They're always going to be a journey from one place to another. And often in diagrams they're represented as arrows, but they can be written down in lots of different ways. This journey could be described as vector A. Often you see it in books with sort of bold print. It could be written as two different numbers like this. It could be the vector 2, 3, and that could be called vector A. Or it could be written as two letters, maybe the journey from A to B, where A and B, the capital A and the capital AB, are two different points, and to get from that place to another place, you have to travel along the vector 2, 3. But no matter what, they are always describing a journey. If they are written as two numbers like this, the one at the top is always describing the journey to the right, and the one at the bottom is always describing the journey going up. And if you have a vector, you can combine it together with other vectors, describing multiple journeys. So say if we have the vector A, which is 2, 3, and we had another vector B, and that was the vector, let's say it's minus 5, 5. Okay, so this one is going 2 to the right and 3 up. So it's something sort of that direction. 2 along to the right and 3 up. This one's going 5 left, quite a long way to the left. But it is going up. Oh, I've drawn that in the wrong place. So it's something like that. Going right through my other notes. We're going 5 to the left and 5 up. And if you combine them together, you could add them together. A plus B, so that means you're travelling 2 to the right, 3 up, and then 5 to the left and 5 up. And you can add them together as column vectors. So it's 2, 3 plus minus 5, 5. And you can add together the top numbers. So 2 take away 5 is the same as minus 3, and 3 plus 5 is 8. So the journey from the beginning goes along A, along B, but overall the journey would be 3 to the left and 8 up. And these are always written like this. You don't have a line in between, they're not fractions. They are a little bit like coordinates, but coordinates are particularly talking about one place. So if I had a point that was here, say, that was the point, let's say it's minus 2, 1, and we had another point, let's say this was, I don't know, 6 and 4 up here. Let's call this point F and this point G. If I want to describe the journey from one coordinate to another, we can use a vector. So that vector there would be how far you have to go from minus 2 to 6. So that's a journey of 8 to the right. And from 1 up to 4, so that's a journey of 3 up. And that sort of forms a triangle there, with a width of 8 and a height of 3. So coordinates are particular places, vectors are journeys from one place to another. And the interesting thing about vectors are they don't have to be in the same place. So you could have another vector that was going higher up, that was going from this point to this point, but it would actually be the same vector. Because we're starting a little bit higher up, we're finishing a little bit higher up, but it's the same amount of distance going up, it's still 3 up. So you can have vectors that are not necessarily fixed in space, but they describe a similar journey. You can have vectors which are parallel to each other. You can have the vector 2, 3, and another vector which is, I don't know, 4, 6. This one goes 2 along and 3 up. This one goes 4 along and 6 up. So it's a similar journey, but it's twice as long. And it's quite interesting sometimes to work out how long these vectors are. And we can use Pythagoras to do that. This one is 2 along and 3 up. So if I want to know the distance of that hypotenuse there, the length of this vector is called the magnitude of that vector. So if that's vector A and that's vector B, the magnitude is written like this. Magnitude. And it's written with two lines either side of the vector. And in this case, it would be the square root of this one squared plus this one squared. What would that be? 4 plus 9, so the square root of 13. Not a particularly nice number, but that is somewhere in the region of 3 point something. Square root of 13. 3.61. So 3 significant figures. This one, it's 4 along and 6 up. So the magnitude of B would be the square root of 4 squared plus 6 squared. 4 squared plus 6 squared. Square root of 52, which is twice as big as the other one, 7.21. That's the 3 significant figures. So the magnitude of each vector can be found by using a little right angle triangle, a little bit of Pythagoras. And the magnitude is quite a nice way to work out how long these are. If a question starts talking about vectors, they're either going to give you it in this sort of style, or they could start talking about coordinates, and if you have coordinates you can work out the journey from one place to another. Sometimes they're used to describe the journey of a shape from one place to another, so you can have translations, which I'm sure all of you have done before. If you're translating a shape, say like a T shape, and you have to translate it by the vector, let's say it's 3 minus 5, that would be taking that shape and moving it 3 to the right, 1, 2, 3, and then 5 down, 1, 2, 3, 4, 5, 6 down there, that should be 5, 1, 2, 3, 4, 5, yeah. And if you're redrawing the shape, you have to make sure you redraw it from the same corner. So my T shape would be roughly like this. Obviously it'd be much more helpful if I had squared paper. But that corner is corresponding to that corner, and I chose that corner to move. And so when I redraw it, the shape has to be starting from the same place. So there's work for you to do on vectors. Details are on your homework. We're going to use Manga High. Good luck. I'll be online. You can ask me for help. Bye. From the Mathematics News Desk, good evening.